In this video, we're going to show how to use Tecplot to calculate a spatial average within a system. The example that we'll use today is the FCC Riser supplemental training problem, and I have already run it out to its int time, which was set to 30 seconds. And one thing that we'll be using here is time average data. So in this case, time averaging was set to start at 20 seconds. We're going to look at calculating the spatial average of Barracuda's calculated time average for particle volume fraction as our example for this video. So to do this, the first step is usually to go to post run, and we want to open our results in Tecplot. And by default, the view that you'll see in Tecplot is the instantaneous calculated particle volume fraction at the latest solution time. So in this case, we've run all the way to 30 seconds. What we're seeing are particles colored by their own volume fraction at this moment in time. For our purpose, we want to look at cell's time average particle volume fraction. So I'm going to double click this quick macro item, and you'll see the view turns into the Eulerian domain colored by time average particle volume fraction. In order to calculate spatial bins of averaging so that we can get kind of an XY plot showing the average particle volume fraction along the z-axis, you cannot do this directly with the function in the Tecplot GUI, but we can do it using Tecplot. And before I jump into that, I just want to make sure everyone's clear with what we mean by bins. So in this case, our system, if we want to get an axial profile along the z-axis, here I see that our k value goes up to about 194. So we have about 200 cells in the z direction. So when I say we're going to use bins, what I mean is if we go with 20 bins, then each of those bins would have about 10 cells vertically. And so we're going to calculate the spatial average of about 10 cells in blocks along the height of this riser, so that we're going to get a profile of average particle volume fraction versus height. So let's look at this. In order to use Tecplot, you have to do scripting, Tecplot connections, accept connections. So now this Tecplot window is ready to be controlled by a Python script. To start your Python script, open a terminal from the Barracuda window, and as long as you have Python installed according to our recommended procedure, you will get into the base environment of Python. And if you've also installed the Tecplot module, then you're all ready to do this Tecplot operation. So here I've already written a quick Python script to calculate the spatial average, and this script will be posted below this video. And let's just walk through this real quick. What we're going to do is import a few libraries that are required to do this: the Tecplot library, NumPy for some array operations, and SciPy stats for the binning operation that we're going to do. This section connects to the Tecplot window that's running, and by default it always goes for port 7600, and so we don't have to specify the port as long as we're using that default number. We are going to read our active data set, which again is the loaded data at 30 seconds for this example. Here we want to get the cell center Z locations for every cell in the system. And so this is kind of a common pattern that you might see if you want to get X, Y, or Z cell position. So we're going to extract that from the Tecplot data. And then we're going to read in the time average particle volume fraction that's been calculated by Barracuda from 20 seconds to 30 seconds. We're going to read that into a NumPy array also. And so after this operation takes place, we're going to have the Z values in a NumPy array, and then we'll have the average particle volume fraction in a NumPy array, and then we can use the bin statistic function from SciPy stats to calculate the bin averages. And as I mentioned, we're going to do 20 bins, And so we're going to divide our domain into 20 sections along the z-axis and calculate the spatial average of this variable along that axis. And then finally, we will output all this information to a new SFF file. And so I've given my SFF file this name, right? And it's kind of a long name, but it says what we're doing, right? It says, okay, this SFF file is going to contain the time and spatial average profile of particle volume fraction. And so we're going to write these calculated results out to this SFF file. And then once we have the results in that form, it's really easy to read them back into Tecplot for plotting, or you could plot them with Python, or you could copy and paste it into Excel and plot it there, right? So once you have it in this text format, it's pretty easy to deal with. So that's our Python script. I'll go ahead and close that for the moment. And here we've already enabled PyTecplot connections. So here we can do Python calculate spatial average profile. That's our Python script. And what we'll see is it runs, it establishes a connection, and then it gives us our terminal back, right? So this is a pretty quick operation, especially on this example data set. It's a fairly small data set. This doesn't take a whole lot of time. Okay, and if we look in our directory at the SFF files, a lot of these SFF files were part of the project setup, right? But this SFF file, this is our new one that we just created. So I'm just going to go ahead and show what that SFF file looks like if we output it to the terminal. So here we'll see this is kind of standard SFF file format where a few of the lines document what the columns mean, and then the rest of the lines are the two columns of data that we've created, and they're just separated by one or more spaces. So with this SFF file, we can actually read this back into Tecplot and make an XY plot. So here I'll go ahead and close that. Let's make a new frame, and we'll just put it kind of next to our three-dimensional view. Let's go to File, Load Barracuda Data, Load Data Files. And our data file was time and spatial average profile. So if we just start typing the word time, is the only thing that matches. We can click on that and say open. And by default, this will plot column 1 versus column 2, which is exactly what we want in this case. So we get a plot of the time average particle volume fraction versus the height of the reactor or the vessel. And if we turn on our symbols, I think we'll be able to see we should have 20 symbols here. We should have 20 little squares marking this because we had 20 bins of data, or 20 bins within our SciPy stats function. And so if you want more resolution on this profile, you can specify more bins. However, in general, you never want to go with more bins than you have cells in the corresponding direction, right? So in this case, if we have 194 cells, you would never want to go above 194 bins, because then some of the bins would have no data in them after all. You would have too much resolution relative to the actual resolution of your grid. So usually I end up doing something like 20 or 30 bins, and a lot of times that gives enough spatial resolution to be useful. But there you go. That's how you can use PyTecplot to extract data from a 3D data set and calculate this type of spatial average profile directly from the Tecplot data.